Okay, so for the first one, we have a piecewise defined function, and they ask us 3 different questions about it. The first question they ask is, what is f of -1? So that's literally asking, what is the value of the function when x is -1? So we just look up, and it is worth 1. So the answer to that one is just 1. Now we get to the limits. Okay, if you don't remember, this little plus sign means we're talking about a right-hand limit. So they're saying as x gets closer and closer to -1 from the right-hand side, what's the value of the function? So we look and we're like, well, let's see, as x gets closer and closer to -1 from the right-hand side, the function gets closer and closer to 1. So that's also worth 1. Okay. Now, negative sign, so it's a left-hand limit. Okay. So the function, as x gets closer and closer to -1 from the left-hand side, well, the function gets closer and closer to 2. So the left-hand limit is just 2. And I assume this one's going to be similar, so let's just look at this real quick. Okay, so g of 2, literally, what's the function worth when x is 2? Well, it's not worth 3. There's a hole there, so it's worth whatever this is, so it's worth 1. Okay. Right-hand limit, as x goes to 2 from the right-hand side, what does the function get closer to? Not what is it worth, but what does it get actually closer to? So as we get closer and closer to 2, the function gets closer and closer to 3. Doesn't matter what it is at 2, just as it gets really, really close. And so for a left-hand limit, same idea. As we come over here from the left-hand side, as it gets closer and closer and closer, it ends up being 3. And then, is there a limit, not left or right hand, but just is there a limit as x goes to -1 here? There is no limit, and the reason is the left-hand limit and the right-hand limit are not the same, so there is no limit as x goes to -1. Extremely quick aside, there is a limit as x goes to 2 on this. It's 3, because the left and the right-hand limit match, but whatever, no big deal. Okay, so this one here, we want to know, is this piecewise defined function continuous at x equals -1? Okay, so sort of like, do we not lift up our pen when we're drawing this function? Okay, well, let's see. So if f of x, let's see, when x is -1, this thing's literally worth 6. If x isn't -1, this is what the function is worth. So basically we want to know, well, do these two things match? Well, if we stick -1 in here, we get 1 minus 1, we get 0/0. That's no good. Okay. What we really want to investigate is the limit of this function, the limit of the function as x goes to -1, the limit of this. Okay. This sort of tells us how the function behaves as it gets closer and closer to -1. And you can mess about with this, or you could do L'Hopital's rule, either way. So let's pretend we do L'Hopital's rule, and we get 2x/1, plug -1 in again, and you get -2, which means the function's not continuous, because the limit is -2, but the function is actually worth 6. So what you end up with is a picture that basically looks like this. As x, if at x is -1, right, the function's worth 6, but the limit is -2. So that means it's kind of pulling one of these moves, and so it's not going to be continuous. Okay, very quickly I'll do these last two. Okay, compute the following limits. Here's a rule you need to know, right? As x goes to infinity, plug in infinity, you get infinity over infinity. Right, so you look at the highest degree, x to the third and x to the third, and that's all we care about because everything else gets totally drowned out. Okay, and if you want to think about it as the x to the third sort of cancel, and all we're left with is 7/2. Now think about what that means graphically. So as x goes toward infinity, right? So if we have a little graph, as x goes toward infinity, our function gets closer and closer to 7/2, to 3.5. So our function literally, whatever it looks like, is going to end up going toward 3.5. Or 7/2. This one's a little trickier. Right-hand limit of, as x goes to 0, of 1/x. Okay, so I'm just going to kind of draw a picture of 1/x. So when x is 1, y is 1. When x is 2, y is 1/2. When x is 3, it's 1/3. And you can sort of see that it starts to look like this. So So this one's asking you to think about this graphically. So as our function goes towards 0 from the right-hand side, what's it worth? Well, it's going to get unbelievably big, right? If we plugged in like 0.000000001 or something, this entire thing is going to become infinity. So this is worth infinity.